For the last few weeks, I've been working on something big. Initially, I was going to make a video about how to use pre-existing tools to make deepfake videos of people. Eventually, from using those, I noticed that there were certain features I wanted to have in a tool like that, so I decided to actually make my own. So then the video turned into me making my own tool to use for the video. And then I was like, okay, if I'm going to be making a tool to be able to make these video deepfakes, I might as well give it a UI, an interface, make it easy enough to use, and then share with other people into a tool that I decided to call TikTok Diffusion. That is this video. Stable Diffusion is an AI image generator. You give it text and it can give you an image from the text. You can also give it an image and give it text and warp the image to look like the text. When you give it text and it turns into an image, you call that text to image. And when you give it an image to warp to the text, you call that image to image. And considering a video is a series of images, you could effectively use image to image on each image in a video to warp the video, then combine it together, and now you have your magic deepfake. This. As you can see, that's really bad. It looks more like a slideshow or a series of images. However, probably be more correct to say a video is a series of related images where these are just completely random images. But I expected that. I knew I was going to have to change some of the settings, but I just wanted to show what it would look like if you didn't do any of that stuff. So, first thing, the most important one, denoising. This slider allows you to control how much the text warps the image. If it's at 0, it does nothing. If it's at 100, it changes the entire image. Using this, you can control the amount of change. The video or the frame that you're changing still has no knowledge of the frame that came before the frame that comes after. However, can make it work like that by just changing the image less. Since if it's at 0, it essentially is the first image, the image that you put in, and since the image that you put in is similar to the image that came before and after, by just simply changing the image less, you make this image similar to the image that came before and after, thereby making the video more consistent across the board. If you were to do something like that, you will get a video that looks like this. This video uses the denoising at about 0.5. The default is 0.75. The thinking here is that I want the video to have half of the original image and half of text that I'm changing it to, because that's what this does. This is what the original video that I was planning to make was gonna be about. Get the frames from the video, use half denoising, take the frames of the video, compile it back into a video, and there you go, you got your video. The thing is, if you compare this to this video that I used in the opening, you can see that they're very different from one another. So, what's going on? Let me explain. If you look at this video, you'll probably notice something. The background here has no change, which is weird. So how could you do this? At this point, I was using a depth map. A depth map gives you information about the depth of things in a video. Things that are closer are going to be brighter, and things that are further away are going to be darker. You can then simply remove the dark parts of the image, and you basically just got a mask that gives you just the person in the foreground. You can then use that to be able to warp the person with the text. However, there are some problems, which is why we ended up here. If you look around, you'll see that there's times when it selects things that shouldn't be selected. There's also the mask around the person in general isn't super exact, and also it fails when there's too many people in the image, or there's too many moving things, or if the camera angle change. It fails in a lot of situations. This is actually like a best case scenario realistically. There has to be a better way. YOLO is an object detection algorithm that divides images into a grid system where each cell of the grid is responsible for detecting images within itself, or at least that's what they say on their website. Instead of using depth to detect people, you can use YOLO to detect people by detecting people. So it doesn't detect depth, it just detects actual people in the image. And it's pretty good at this too. If you look at this image, you can see that it detected all of these people automatically. So pretty good. It also gives you a mask around the person as well, and it tracks individual people in the frame, allowing you to be able to warp each part of the image differently, allowing you to be able to use image to image to warp the image on different parts of the image individually. You can effectively make one person into Emma Watson, somebody else into Gal Gadot, and somebody else into Jessica Alba. You can just do that. Here is an example of that. This is the original video, and this is the warped video. What you're watching has all of the mentioned stuff. It has the mask, the individual person tracking, and it's using the lower denoising, which, as I said, is the amount of change that you're allowed to make to each individual frame. Oh, and by the way, I noticed that when it comes to the denoising, I noticed if you set this to be very low, like 0.05 or to 0.01, it actually still is enough to alter the identity of the person. And I also noticed that if you're changing the video, you want the denoising to be as low as possible, because when it's very low, it means that the whole video has less change overall and the entire video becomes more consistent. So you actually want this number to be as low as possible, because if it's high, you're gonna put a bunch of flashing, but if it's very low, the video becomes way smoother. So in this video, it's actually using that lower denoising that I talked about. And also, it restored the faces of the people using another thing. But wait, there's more. Rife, rational inference for everyone, or at the very least, that's what it should be called. Rife is a tool that allows you to generate extra frames using 2 neighboring frames. It's usually used for creating ultra slow-mo video using only 2 frames, or for increasing the frame rate of a video by taking, say, a 30 FPS video and turning it into a 60 FPS video, or a 60 FPS video and turning it into a 240 FPS video, or whatever. It does this by taking 2 neighboring frames and inserting in between frames in between those frames. So basically, Rife smooths out the video by creating an average of the 2 frames that are around it. So why is that important? If you look at this video, the generated one, you'll still see that it is a little bit about haziness and some amount of shifting and stuff. If you take this video and then you use Rife, so this is the original rendered one, and if you look at this one, which is the Rife version of the video, right, shortened to R and TX because it's extreme, you'll see this without Rife and with Rife, and you'll see that this one is a lot smoother and there's not as much big shifts throughout the image and it looks less flashy. And that's another thing I integrated in TikTok diffusion, which is what I'm calling it, by the way. Also, the important part is this is twice as fast as this, because you render half the frames, and the frames in between those frames, you simply generate those frames, meaning that this is both smoother and renders twice as fast as this. But there's even more. Deepfakes have existed for a while, but they mostly change the face. This, it changes the entire body of the person. This means you can change the skin color of the person, so you can make a black person into a white person or a green person into a white person, so you're not limited to replacing realistic things with realistic things. In fact, you can replace people with anything that Stable Diffusion can understand, like, say, for example, anime characters. You can replace a human with an actual anime character. Remember the Emma dance video from earlier? This one? Yeah, well, this is it, but with anime. The character in the video is Makima. Makima is this character from this anime, Chainsaw Man. Anyway, here's the video. So as you can see, you can replace people with even things that aren't even real, as long as Stable Diffusion knows what it is. But the thing is, even if Stable Diffusion doesn't know what it is, you can add it to Stable Diffusion. So for example, you can add Makima, for example, is not in the mainline Stable Diffusion. In order to be able to use this, I had to use a model that was custom that had Makima in it in order to be able to do this. And that means that you can add your own data to the model as well. Like, for example, you can add yourself. So in keeping with that, I'm going to show you a video of me replacing someone. Again, I didn't want to do a face reveal for this video, but I decided that it was too necessary to have a realistic interpretation. So I guess here it is. So with this, you can see the original video, and then I replace her with me, and you can see there, it's really good at replacing with your custom data. I mean, this looks exactly like me, like underneath the suit, it looks exactly like this. So the likeness is uncanny, so it's really good. I then went on a bit further and decided to add another anime character to Stable Diffusion to be able to use to turn people into. Textual inversion is a way that you can add data to Stable Diffusion. There's a bunch of different ways to add data to Stable Diffusion. I'm not going to talk about all of those, but this is what I decided to use to do this. The character I decided to add was a character named Power, which is a character from Stable Diffusion, a character from Chainsaw Man as well, just like Makima, and then I use that to generate videos. If you look at this video here, I have both Power and Makima in the video, but there's some problems. I would say that if you look at Power, it just doesn't look that good. It isn't that well put together, and this goes to show that depending on how you train things, you can definitely run into issues. Also, Makima doesn't look that good either, but this is more because Power wasn't looking good. I had to adjust the settings to try to make it look better, and I actually ended up making Makima look worse. There's a lot of reasons why this didn't work. One of the big ones, power is already a word that is used by Stable Diffusion. It already knows what power is, and it doesn't think it means this. It thinks it means like this. Trying to make power mean power is difficult. So then I turned to cosplay to be my saving grace. Take someone who already looks like Power because they're cosplaying as Power, and then replace them with Power. That way I won't have to make as much change to the image, and it could potentially save it. You can see that maybe this looks even worse. Honestly, it does not look that good. This is kind of scary, honestly. It just doesn't work. That's when I decided to use a different method for fine-tuning Stable Diffusion and adding power to Stable Diffusion. There's inversion, dream boost, hypernetworks, LoRa, custom diffusion, and traditional fine-tuning. There's a ton of different ways But for a lot of reasons that I don't want to get into right now, because this video isn't about that, I decided to use LoRa as the main way I would train power into Stable Diffusion. I also increased the quality of the data by adding more images than what I had before. Anyway, here's the video. As you can see, this is way better. It looks way more like how Power looks from the anime, and I think you can get this to look better, but I wanted her to look like how she looks in the anime. LoRa's, which is what I'm calling them, LoRa's also train faster and are smaller than other ways of fine-tuning Stable Diffusion, not smaller than textual inversion embeddings, which is what you call the things for textual inversion. However, they're still a lot smaller than the other ways, which can be gigabytes when this is megabytes. Okay, so it's like way smaller than those. Also, this network that I created isn't just for, turning people into power or whatever. It can just generate images of power, as you can see here. And if you want to be able to use it, I'll link the link to the thing here or in the description so you can be able to use it yourself. But yeah, I also made a bunch of other tests. There were Emma ones, there were Gal Gadot ones, there were Emma and Gal Gadot ones, and a bunch more. If you want to use TikTok diffusion, which is what I'm calling it, you can go to this link. The GitHub page should be linked in the description. You can check here as well. Keep in mind, this is alpha. This is the first version. I only had about a week or so to be able to make this from when I made the last video. It definitely could be better. It has to improve a decent amount. So the amount of improvement is going to be dependent on how much people even like something like this. I don't know how interested someone would be or how interested people would be in this sort of thing. So depending on how interested people are, I'll know how much improvements I can actually go to make to this sort of thing. And before you leave, I want to leave you with one of the videos that I did where I replaced 3 other people in it. It's this cool video. So yeah, and make sure to like and subscribe, and I'll catch you in the next video.